So the paper we're talking about today concerns viral variants, and what it presents is a conceptual framework that I use to understand the impact of these viral variants. My name is Andrew Badley. I'm a professor of infectious disease, and I'm going to be talking about the article called The Yin and Yang of SARS-CoV2 Mutation and Evolution. And this will appear in an upcoming issue of the Mayo Clinic Proceedings. The first thing to understand is that viral mutation is inevitable, and that viral mutations accumulate over time. So the more viral replication there is, the more viral variants you will have. The reason for this is that the replication machinery that viruses use make mistakes. And so the more replication there is, the more mistakes they make, and those equal mutations. Now, these mistakes or mutations can impact the biology of every step in the viral life cycle. This impact on biology can be beneficial to the host, meaning it causes less disease. It can be neutral to the host, meaning there's no impact, or it can be harmful to the host. For example, it causes more severe disease. These mutations can affect 5 things that are important clinically. One is attachment. This is the virus attaching to a cell. If the viral mutant does not attach to the cell, it cannot cause infection. The second is replication. If the viral mutant has impaired replication, that virus spreads less. The third is pathogenesis, or the ability to cause disease. Some viral variants have a reduced ability to cause disease, and so far, thankfully, we haven't seen many viral variants that cause worse disease. Next to last is the susceptibility to neutralization from antibodies. We are using antibodies more and more as therapies for SARS-CoV-2 infection, both administration of monoclonal antibodies, administration of convalescent plasma, and of course, receipt of antibodies following a vaccine. The last biology that can be impacted by these viral mutants is the susceptibility to antiviral agents, such as remdesivir. Now I'll provide a brief summary of what we know about the biology of the viral variants that we've seen so far that are of clinical importance. First is that the South African, the United Kingdom, and another mutation called the D614G mutant all appear to be more infectious than the original strain of SARS-CoV-2 called the Wuhan strain. We do also know that the D614G mutant and the UK mutant are effectively inhibited by monoclonal antibodies and convalescent plasma. The South African variant may have reduced susceptibility to monoclonal antibodies and convalescent plasma, and perhaps vaccine-induced antibodies, but the effectiveness of these agents is not zero. So although there's reduced susceptibility, these agents likely still have some impact. And finally, we have not yet seen clinical resistance to remdesivir, and this is a wonderful thing. One probable reason why we haven't seen resistance to remdesivir is a lesson learned from other RNA viruses. We know that if Ebola or MERS virus becomes resistant to remdesivir, then this virus is less fit, meaning it replicates less well. If the same is true for SARS-CoV-2, that means that the resistant virus will not dominate. So how does that impact us today? Viral variants will continue to occur if we have ongoing viral replication. So the best thing we can do as individuals and as society is try to prevent infection. And that includes universal masking, trying to acquire immunity either through vaccination or recovery from infection. And finally, if people are infected, seek early diagnosis, and if early diagnosis prevents spread by quarantine, and early treatment to reduce the viral replication. Thank you for your attention.
We hope you found this presentation from the content of our website valuable. Our journal's mission is to promote the best interests of patients by advancing the knowledge and professionalism of the physician community. If you are interested in more information about us Our homepage is www.mayoclinicproceedings.org. There you'll find access to information for our social media content, such as additional videos on our YouTube channel or journal updates on Facebook. You can also follow us on Twitter. More information about healthcare at Mayo Clinic is available at www.mayoclinic.org. This video content is copyrighted by Mayo Foundation for Medical Education and Research.